This is the second sanding I'm doing on Intrepid. The grain is filled in quite a bit more than it was with the first coat, so I think by the time I spray another coat on here, it's going to be pretty well filled in. On the decks, what I've done, I've sanded the decks and just gone over it with a roller. That way, with a roller, if you used a brush here, every time you hit one of the ribs here, you would have a run going down the ribs. So I used a roller here, just trying to build up the bare wood spots on the back here. They're getting a little bit lighter, but I mean, unfortunately, unless you strip it, which is exponentially more expensive than just putting a couple of coats on, it's not really any other way around it. The gunnel here I think is cleaned up pretty good. There I put some epoxy in it and filled the gouges, and also make sure this bare wood was sealed. It was all bare wood on this edge here, so it's cleaned up a bit. Still have a lot more sanding to do. It's probably about another day, or well, 6 hours of sanding on the back here and then varnishing it, and then it'll be time to put it together. It's the end of March here, and the power has been off in my shop for I guess this is the third day now. I've been here 35 years. I've never had the power off this long. Anyway, it was quite a nice storm Friday and Saturday. Since there's not a lot I can do without the power, I thought, got enough light, I can get working on this device for Intrepid. I think in an early video I showed how I took the guts out. What I have to do now is take the stuffing box off the front, and that'll be pretty well everything out of here. Then I'm going to take it down to the sandblaster and get it sandblasted, and then I can put a nice coat of paint on it. One thing the sandblasting doesn't really get rid of that well is things like this rubber gasket. I'm going to just get a chisel and see if I can pry that off. There will also be a rubber gasket up here on the stuffing box. The other thing I do on this type of stuffing box is sometimes they are machined with a slight angle on them. I always make sure I mark which way is the top, because this can be rotated 180 degrees, and if there is a slight angle on it, the alignment of the shaft won't be right when it goes onto the device, or it goes onto the back of the engine. Just gonna see if I can flip it over here. Here on the bottom, there's a lot of crap. I'm just gonna take that off with a chisel as well. And what do you know, the power just came on. So anyway, I'm going to get this stuffing box off, get as much rubber off as I can, and I'm going to get it down to the sandblaster. It's the day after that I've basically coated the device with phosphoric acid, and then sprayed it down. After it had worked for a few minutes, I sprayed it down with water to neutralize the acid. The acid leaves a microscopic etching in the metal, and it does have a bit of a flash rust, but the epoxy primer I'm going to use, it's a Pore 15 paint. It's actually designed to go over the rust, so this is a very light rust. And here I've noticed even from day one, this was not the best casting. It's got some major blowouts in it, which were probably there from day one. What I'm going to do is before I coat this with the epoxy primer, I'm going to go over it with this JB steel weld here in these pits here before I prime it. The other thing I've noticed is the sandblaster, when they were handling it, they did manage to break off a couple of these brass studs that hold the cover on. I'm just going to drill those out and re-tap them. I'll probably just use stainless, which will be a lot stronger anyway. Also here, it's going to be hard to get the cover to seal here, where we've got these blowout holes here, so I'm going to fill those And I notice after that I'll turn it over. There are a few on the inside I have to treat as well. Just getting ready to paint the device. I've drilled and tapped out these broken studs. I've just got bolts in there to keep the paint from filling up the holes. Put in a bit of JB weld on those blow-throughs in the casting. This is the product I'm going to use on it. It's a POR 15. It's a very tenacious primer. So anyway, I'm going to turn it over and do the inside first, then I'll turn it right side up. And hopefully I don't get the cat involved in this. I've got the device for Intrepid here. The boat's all varnished, looking nice and shiny. Got the two coats on the inside here. The actually it's probably three. I've used the Epiphanis gloss varnish, which has a pretty good UV protection. I've also done all of the seats over there on the bench, so now I'm getting ready to install the device. I've had it sandblasted. It's all coated with epoxy paint on the inside, but one thing I did not notice, and interestingly enough, Paul Donington, the minute he walked in the door, said, "Oh, look, the corner's missing out of that device." This is an unusual device. It was probably one of the earlier ones that they made at Gravette's. It's quite a bit thicker on the flange here, and it's cast iron, whereas most Gravette's were aluminum. But one thing I did notice that Paul pointed out to me, which I had overlooked, was the corner here. It's a faulty casting. The bad side is that there's really not a lot of sealing area. If I look at this side, that's a 1-inch wide flange, which will make a nice seal against the bottom of the boat. If you go back to the beginning when I was taking this out, it had a lot of Sikaflex kind of smeared in there, and I think that was to compensate for this. I don't think I want to put it in like that. And cast iron is really difficult to weld, if you can even find somebody to do it. So what other than that, the device is in pretty good shape. It's nice and thick. But because I don't want to weld cast iron, or I don't know how anyway, what I'm going to do is I'm going to make a pattern. And I'll see if I can find a piece of 1/4-inch plate. What I'll do is I'm going to JB weld it, which is really strong stuff, and I'll drill it and put a couple of pins in here. That way it will have a nice full flange. So I'm just taking a pattern off the one side here. I've traced, I guess, the port side, and what I'm going to do is I'm going to just make a pattern here. I can see here where it was supposed to go. I don't know, there's probably a problem with the casting. I think what I'll do though, before I define this edge for my pattern, is I'm going to clean this up with a grinder and get a nice smooth curve. That way I can pin it a couple of different directions, and it'll be really strong. Now there's my pattern. All I have to do now is find a piece of 1/4-inch steel plate to make that out of, and I'll get ready to put it in. I've decided to do this cutting outside, that way I won't end up with these iron filings all over my shop. So I've got this zip cut saw. Okay, what I'm going to do now is I'm going to take this to the milling machine, drill a couple of pinholes here, then I'll clamp it back in place. I can use a drill just to make a little protrusion there, and then I'll just pin this in place. This is the stuff I'm using, the world's strongest bond. Ideally, a lot of people would say, why don't you weld it? The problem with welding cast iron is you have to heat the whole thing up. That device probably weighs 60 pounds. It would take an incredible amount of heat, and it would probably do more damage than it's worth to weld it. So I think this is the best solution for the situation at hand. The device is installed in Intrepid, or the housing. Actually, I've got the skeg in. It's all centered up, and both sides are repacked. I was getting ready to put the prop shaft in, which is on the bench over here. I got looking at the U-joint, universal joint. These are just steel. A few people have tried stainless steel ones, and they don't even last one season. For some reason, stainless steel does not like running against itself in a water environment. The regular steel seems to last a lot longer, but this one is... I could put it back in, but it probably in 2 years I'd be getting phone calls saying the motor runs but the boat doesn't move. And I do have some new ones here. They're getting kind of hard to get now. There are a couple of different types. This is a pin and block type, which I prefer. I'm going to go and I think I have a sliding pin type. I'll just show that. I don't like those because the pin can come out and then it starts notching the device. But anyway, I'm going to do a video on how to change a U-joint because this is a pretty common thing. So there's what I've got, and there's the new one. I prefer to get the ones with no set screws drilled. That way I can match the set screws to the existing thing. And you can see this one has been put on with set screws, but there's no way those things are coming out. The only way to get it out is to use a zip cut wheel and cut this thing off of the shaft. So that's the first thing I'm going to do. This U-joint here, it's an 1.5-inch U-joint. It's a little bit bigger, but It'll serve to illustrate what I don't like is the other type of U-joint that's available is this is a sliding pin type. You can see this pin here is bigger, and it's drilled to receive this pin. Now this pin just slides through. The only thing holding it in is a little metal a metal spring clip. So all you have to do, I think the intention of these was so you can change the universal joint without taking it off of the shaft. The idea being you knock this little pin out with a punch and the whole thing comes apart. In a device, in a Disc Pro, if that pin comes out, you start hearing a little ticking sound. I know a few people have done it. I've had it happen. I've also seen a couple of devices with big, especially the aluminum ones, where there's a big notch machined into the side of the device where that pin is coming out. Till somebody twigs that there's something going on. So anyway, that's the that's the sliding pin type, which I don't like to use. This is the pin and block type. So I've got it clamped in the vise here, and I'm just going to get the old one off.